Welcome to part 2 of section 4.8, and today we're going to talk about complex conjugates. We're going to start with a quick review of complex numbers. So we have I, and I represents the square root of -1, which we just leave it as I, or I to the first. I squared, well that's really, I times I. Or think of it as the square root of -1 times the square root of -1. Well, anytime that you're squaring something, I can rewrite this as the square root of -1 squared. So now I have the square root and I'm squaring it. Those are inverse operations, and you're going to be left with just -1, whatever underneath the radical. So I cubed. All right, can I get I cubed from my preceding terms? And I can. Well, that's really, I times I, which we could think of as just I times I squared by grouping the last two. Well, I is I squared is -1, so I'm left with I to the fourth. So we have I times I times I times I. So let's say I group them in pairs. That's going to be I squared times I squared. I squared is -1 times -1. So I'm left with +1. I to the fifth. Okay, now I have 5 i's that I'm multiplying together, which I'm going to say, okay, you can group them any way you want. This is going to become I squared times I cubed. I squared is -1, I cubed is -I, and negative times a negative becomes a positive. So this is positive I. And we're starting back at our pattern. I, -1, I, +1. And it goes back. So it repeats patterns of 4. So hopefully you remember when we talked about complex numbers. And a complex number was just any number in the form A plus BI. So we had a real part and an imaginary part. Well, a complex conjugate is going to be the opposite of that. We have A plus BI, and then you could have A minus BI. These are conjugates of each other. It's where your middle term, or not your middle term, it's where your sign is opposite of each other, but the values themselves are the same. We've talked about conjugates before. Specifically, we talked about them when we were factoring, when you had differences of squares. For example, x plus 5 and x minus 5. Those are conjugates of each other. What happens when you multiply two conjugates together? Well, let's take this example up here. Let's multiply them. So we're going to FOIL. We get x times x times -5, +5 times x, and +5 times -5. What happens to our middle terms? Well, they're opposites themselves, and so they add up to 0. And you're left with x squared minus 25. We called those differences of squares. Well, that's going to be what happens when you multiply two complex conjugates together. So let's take A plus BI and multiply it by A minus BI. And it should be the same thing that we got up here. Our middle terms should be opposite. Well, A times A squared, A times -BI, and I always leave my values in alphabetical order, so I'm going to write it as -ABI. Then you have BI times A, and they're both positive. And then you have a BI times a -BI. So you get negative, B times B is B squared, I times I is I squared. Well, yes, our middle terms are opposite. And so we're left with a squared minus b squared times I squared. But if you remember what I said earlier, you cannot leave any terms with I has an exponent larger than 1. You have to break them down and simplify them. And I squared is negative 1. So this is really a squared minus b squared times negative 1. So our final answer is going to become a squared plus b squared. And this is a shortcut right here. So if you're multiplying two complex conjugates together, all you need to do is square the first term, square the second term, one of the b's, doesn't matter if it's a positive or in the negative, and it'll always be plus for your sign. Well, let's start by being able to identify the conjugate. So in example 5, part A, we have 6i. And if I ask you to tell me what the conjugate of 6i is, well, you should know your answer is going to be negative 6i. So it's going to be the opposite sign of the imaginary part. For B, you have 6 minus 3i. Well, the conjugate is 6 minus 3i. Remember, you want to do the opposite sign of your imaginary. So it's going to become 6 plus 3i. Okay, you may remember from the previous video, we talked about the operations that you can do with complex numbers. We said that you can add them together, you can subtract them, and you can multiply them. But we have not talked about how to divide them. And that's what we're going to do right now. So example 6a, we have 4 minus I divided by 6i. Well, if you remember, we talked about radicals before. We said you cannot leave a radical in the denominator. Remember, I really does represent a radical. It's the square root of negative 1. So if I can't leave a radical in the denominator, I cannot leave I in the denominator as well. And how do we remove radicals in the denominator? Well, we multiplied them by their conjugates. So that's what we're going to do here. What is a conjugate of 6i? Well, you should be saying negative 6i. So if I multiply the denominator by negative 6i, I also need to multiply the numerator by that same value. Because remember, if I simplify that, it's really 1. Just represents a value of 1. Okay. I'm going to focus on the denominator first, do that multiplication, and then we'll talk about the numerator. You have positive 6 times a negative 6, so that becomes negative 36. And I times I is I squared. Well, I squared is really negative 1. So you're really doing negative 36 times negative 1, and it becomes a positive 36. Okay, for the numerator, we are going to multiply everything in these parentheses by negative 6i. So we need to use a distributive property. Negative 6i times 4 becomes negative 24i. And negative 6i times negative I, well, negative times a negative is a positive, and we get 6i squared. Alright, so I squared, remember, is negative 1. So this is really negative 24i minus 6. Now we cannot subtract those two terms. Those are unlike terms. What you're going to have to do, though, is you need to take a look at negative 24, negative 6, and 36. All of those numbers are divisible by 6. So you need to factor out a 6 from the numerator. And then specifically, we're going to factor out, just a positive 6. But before I do that, I'm going to rewrite them so it looks like this. Negative 6 minus 24i divided by 36. I always like to have my real part written first. Okay, so let's factor out that 6. And I'm left with negative 1. Negative 24 divided by 6, you're left with negative 4. Well, 6 then divided by 36 is 1/6. So you're left with a 6 in the denominator. So my final answer is going to look like -1 minus 4i all over 6. Or maybe you want to rewrite it, -1 over 6 minus 4 over 6i. And that's fine. If you break it into two fractions, in that case then I could simplify 4 over 6. And really have -1 over 6 minus 2/3 I. This answer here is equivalent to this answer. So either one will be acceptable. Okay, we're going to practice this more in class the next time I see you. So good luck.